it on your desk and I'll look up
For this?
there. It's your homework. It's a homework.
What day?
Oh, can we just like erase that and write math in this class? This is homework though, right?
No, it's not. Oh, it's just classwork. You don't have classwork.
What day is the last day before break?
Like the day, like the day of December?
Yeah.
I don't know.
I think it's the 16th. Last year was the 17th. This year it'll be a few days.
All right, students will be able to solve quadratic equations. By completing the square. This sounds similar to method 2. Taking the square root is a completely different process, and you're going to see a few differences. Completing the square is a process of rewriting a quadratic as a perfect square trinomial. So it can be solved by taking the square roots, the same method we did yesterday and the day before and on the warm-up, but there's a trick to it to get it to that point. You can use completing the square root for quadratic expressions that are set up as ax squared plus bx plus c. To complete the square, you can add a c term by using the formula b over 2 squared. So check out x squared plus 4x. This is not a perfect square trinomial. A perfect square trinomial, remember, is going to look like this. In the end, when you factor it, it's going to have one binomial, and then you square it. It multiplies by itself twice. I can't get that with x squared plus 4x, so let's make it. I'm going to start out by using this formula, b over 2 squared. Write that again above it. My b value is 4, so let's plug it in. 4 over 2 squared becomes 2 squared, which is just 4. 4 divided by 2 is 2. 2 squared is 4. That is your new c value. You just found a c term that you can add on. So I'm going to plug that in. And this 4, if I were to place it here, just created a perfect square trinomial. How could I factor that? What 2 factors would I get, Wyatt? Say it again. I can't divide it by 4. The x doesn't have a 4. X squared. Yeah. X plus 2. And when you have x plus 2 listed twice, remember what I said you could write it as? The goal is to make it x plus 2 squared. That is a perfect square trinomial. You just created it. You can literally do that for any quadratic that is set up as ax squared plus bx plus c. Tony.
How is that solving for x?
We aren't doing that yet for a and b. I just want you to practice completing the square. So your first 2 examples are not solving for anything. This is not the complete aim. I just want you to get in the hang of how to make a perfect square. Look at x squared minus 8x. What was the formula again to complete the square, Sarah? Write that above it. What is my value of b for this one, Kingston?
Oh, 8.
And it's not just an 8, but a negative 8. Okay. So this plugs in negative 8 over 2 squared. Negative 8 divided by 2 is negative 4. Make sure parentheses are still around it. Negative 4 squared is 16. Place that where the c number would go. Your c value is now positive 16. If I factored this, what 2 factors could I create? My quiet talking one. And it's -4?
Yeah.
Okay. Yeah, because -4 times -4 is positive, -4 plus -4 is negative. That would work. And so you just made another perfect square trinomial. Remember, that is the whole goal of this method. We need to make something that can be taken the square root out of. That's the only way it can work. So that's just the process of completing the square. That's the biggest challenge students have, is getting this part set up. Then it's the same steps as yesterday. Your turn. Try x squared plus 12x. Complete the square and tell me what your perfect square binomial would be. You got 30 seconds to set it up. And silent hand if you have the answer. Felix. Great. And what was your C value that you got? Yeah, 12 divided by 2 is 6. 6 squared is 36. So there's your trinomial. There's your perfect square. So that method is going to start getting really familiar. That's like the only thing that's different, and the thing that just makes students a little bit confused on these types of problems. Yeah.
Do you solve for x because it's equal to 0 like an a, it would be equal to 0 because it's subtracting 3. Do you solve by x by making it so that it will equal 0?
Yeah, you're one step ahead. You're looking at a. Yeah. Okay, let's do this one. But before we actually solve it, I want you to think like a mathematician for a second. I told you guys that there's going to be 4 methods. And a few of you were like grumpy on Monday and were like, why don't I just factor everything? And you were like, I just kind of want to like always take the square root. And a few of you were like, I just want to learn like the 4th method, which can be used in every quadratic. Why do I have to know all 4? And here's the reason. If you think about basketball, if you watch like the NBA or even like your own team, maybe the best basketball players can like do everything. They can shoot a layup, they can go shoot a 3-pointer, they can get fouled and shoot a free throw really well. If you only know how to shoot layups and you get the ball, you're not going to be very effective. You could try, like you'd be pretty decent maybe if you're really good at layups, but then if you get the ball at the 3-point line, you're wide open, you might not be that great in the end. In the same way, like an NBA player who can only shoot 3s is probably going to be pretty good, but they're not going to be the best, because then if they try to drive to the basket, they don't have that skill. So kind of the same thing, that analogy applies for quadratics. All 4 should be interchangeable in your pocket. You should be pretty good at all of them so that you can use it when it's appropriate. What? Larry Bird was good at passing. He was pretty good at most everything. I'd say the most complete player right now, if you guys watch the NBA, is probably Devin Booker on the Phoenix Suns. If you watch him, he just put up 51 points in 3 quarters. That's 3/4 of the game yesterday. He put 51 points up, and it's because he could drive, he could hit fadeaway like mid-range shots, he could shoot like really long 3-pointers. He's just a really good player at every part of the game. So same analogy, use it in math. This might not be your favorite method, but you should still have the access to do it. Why? Yeah. Moving on, 3, 2, 1, back to the board. I want you to solve this one by completing the square. However, but instead of just being a robot and knowing you're going to do it by completing the square, I want you to try to factor it. And then after you try to factor it, if you were successful or not successful, jot down why you could factor it or why you couldn't factor it. Then if you couldn't factor it, I want you to see if you could take the square root like yesterday. If you couldn't do that, think about why. Turn and talk to your partner for a minute. Try to factor this thing and see if you can make it work. Go. If you can't factor it, try to take the square root. Three, two, one. Could I factor this? Silent yes, silent no. I heard some people like think they got one that they could factor, and we'll test it out. If you said no though, tell me what you tried, what convinced you to not do it, Tony.
So I put two parentheses and I did x and x, but then I realized that no factors of -3 can make a -4.
If you're trying to get to -3, you could do -3 times 1, but -3 plus 1 is not -4. That doesn't work. You could try 3 and -1. That makes a -3, but 3 minus 1 is 2. There is no way that you can factor this. This thing is not factorable. So I can't use method 1. Could I take the square root of this thing? Yeah. -4 times 1 is not -3, so it doesn't work. Wyatt, check this out. -4 times 1 doesn't equal it. Okay, it's close, and it's really frustrating. And this is like the what starts to get students a little frustrated in algebra is I'm now layering in a whole bunch of different quadratic problems. I'm not just starting with ones that always factor like before. So you need to start looking at this and being like, I can't factor it, I can't take the square root, and go down the list of your methods. Addison, comment or question? Did you want to talk about the square root? No. Back to the question I had before. Could I take the square root of this thing? Let's try it. Tony, comment.
Yeah, okay, I know this is weird, but it's just an idea. Could you leave the 3 on the right side so that it's just x squared minus 4x equals 3, and then do x minus 2 times in parentheses and then x plus 2 in parentheses equals 3? And
no, because x minus 2 and x plus 2 gives you x squared minus 4x minus 4, not that. But you're on to the right track. That's kind of the start of how to complete the square. Here's how I couldn't take the square root. Because this thing has an x here, if I take the square root of it, that does not work. The -4x cannot take the square root, and that's not the inverse. So method 1 doesn't work, method 2 doesn't work. We are on to our third method. Here's how I'm going to complete the square. Because I have this thing in correct form, a squared plus bx plus c, I'm going to be able to use my third method by completing the square. I'm going to move the c value to the right side. Because I can't take this as a perfect square, I need to start rearranging this thing and making a new c value. So this turns into x squared minus 4x equals 3. How did I find a new c value? What was that formula we practiced in example 1? There is that formula to find a new c value. Flip back to example 1. Look at that formula that you should have written 3 times. There was that formula that you're going to rewrite a lot today because it needs to be in your memory. Tony, what was the formula?
b over 2 squared.
So to get a c value that you can take a perfect square of, always use this formula, b over 2 squared. My b value is -4. Square it. -2 squared is +4. So your new c value goes here. But in order for it to be algebraically correct, what do I also have to add 4 to? Elliot? You also have to do it to the right side. I can't just leave it to one side of the equation. I added 4 to the left. You need to add 4 to the right. Okay? Yeah.
Did we not do that with the other equation?
We didn't because I wasn't an equal sign. I was just having you practice the method. 3 plus 4 is 7. Okay, from here, I just created a perfect square trinomial. That was my whole method. Let's factor this thing out. This would become x minus 2 and x minus 2 equals 7. X minus 2 times x minus 2 can be written as x minus 2 squared. Does this look like a problem from yesterday or Tuesday? Could I take the square root of this thing? That was your whole goal. Go ahead and take the square root of both sides. X minus 2 equals plus or minus root 7. Final step, get x by itself by adding it to both sides. And Tony mentioned on the homework or the warm-up, like, could I just write it as 2 plus or minus root 7? And this is an okay answer. You don't need to put 2 plus root 7, 2 minus root 7, if that's simpler for you to write it. Elliot, professional, please. Professional, please. Okay, look at B. X squared plus 16x equals 36. It's already moved to the right, so you can start making a perfect square. But before you complete the square, I want you to look at this problem. If I move the 36 over, it looks like that. I'm just having you think about this because I don't want you to be a robot. Could I factor this trinomial? 1 minute, turn and talk, go. If I move the 36 over, could I factor that thing? Think about your factors of 36. Are there two things that multiply and add to 16? 18 and 2? Maybe. Okay. It's fine. The class was really boring, Sasha, the past 3 days. 3, 2, 1. Can I factor this thing, silent hands? Sarah, what factors do you get? X plus 18, x minus 2. If you multiply those, you get negative 36. 18 minus 2 is 16. So this method factors and it works. If you had this on the test and you were asked to solve it, you should definitely do that. This took about 30 seconds for me to think about and then jot it down. I'm going to annoy you guys and we're going to do the same thing, but I want you to see that you can also use the method, completing the square, to get the same answer. So let's jot it down to the right. This right side should be completing the square. The left side, you showed it factored. Where? It's 18. Negative 18. There you go. Sure. Thanks. Okay, track the board. If I want to complete the square, what is my first method, or my first step in completing the square? Kieran, give me that formula. You wrote it down 3 times in example 1. Okay, that's going to complete the square. So let's plug in b. b is 16 over 2 squared. 8 squared would be 64. Where do I put the 64? Where do I plug that into, Mariah? Okay, and anywhere else? You also add it to the right side. You do not just add it to the left. That is not algebraically correct. So let's simplify things. X squared plus 16x plus 64 equals 100. Can I factor the left side now, Kylie? What do I get? Good. You now have a problem where you can take the square root of. Elliot, hands to yourself. Addison, when I take the square root, what happens to the right side? Hello. It is 0, yeah. Right. Is it just positive 10? When you take the square root, what happens? plus and a minus. So this is one of the most common blunders of algebra students for completing the square, taking the square root. You have to have both. Maya, help me finish this problem. I have two options. Okay. Okay. And what's that answer going to be? Okay. And what's the second option? Good. And what's your answer? Good. That worked. Check that off. You got the same thing factoring. I showed you both ways just because I want you to see that it works, but as mathematicians and as you perfect these 4 skills, you should always choose the simplest. This is definitely one I would factor. I would not choose completing the square for this just because it works for factoring and it's way simpler, but it does work for every method if you do it correctly. Yeah.
How did you add 64 to 36, but then 64 spawned again?
Over here. So because when you have equations, you have to maintain equivalency, Elliot. I'm gonna start counting you. Please be professional. If you only add it to the left side, you don't maintain equivalency. It's like a weight. You can't like put something on one side of the scale and then have the other side just like hang there. You need it to balance. So as soon as you add something to one side, you gotta add it to the other. It's kind of like when you solved an equation.
If it was an addition, why didn't you subtract it on the other side?
Because I just plugged it in. I didn't actually do the opposite. You're thinking of an equation. Like this equation, I did the opposite. Do you see that? But I still subtracted 2 times. You can plug in any number to any equation. I could add 1,000 to the left side and 1,000 to the right side. You could do that, and that would be a legal math move. It's not going to help you solve it because 1,000 doesn't help you complete the square. But in any equation, I could add 100 to this side and add 100 to this random equation, and it would be legal. It doesn't help me, but you could do that. You could, but it's not going to help you. And like you can get any equation and try to, but like your goal for a math problem is to solve it. If you have an equation, you want to solve for x. And so you can like play around all day and just keep adding numbers, but it's just going to kind of keep running you in circles because you won't actually get to the end answer. Cool? Okay. Okay, these 2 problems, it's your turn. I don't want you to be a robot and complete the square for both. I want you to go down the checklists with your partner for the first your turn and the second your turn. Try to factor first. If you can factor the first one, do that. Do not complete the square. I'll give you a hint. Both of them, there's going to be one that can't factor, and one of them can factor. So try to find the one that can factor. The other one, you'll have to go the second or third rounds. I'll give you...
Yes. I'm so smart.
Wait. None of them factor.
Wait, yes it does. This one
Does
factors.
-11 factor?
Yeah, it's -11. No, it doesn't.
Ooh, okay. This is a good one to look at. If you have 11 on the right side, in order to factor it, you need to move it over to the left. So if you move it over to compare it to factoring, you're going to try to multiply to a -11, but add to a -10. So your factors of 11 are 11 and 1, and that's the only thing. If you have a -11 and a +1, that guy is going to work. So if you factor it, you have to make it 8x squared plus bx plus c. The 11 has to move over. Do you see how I made that a negative? because it wasn't ax squared plus bx plus c. It was on the opposite side. So I moved it over to there. Try that. Obviously, the second one now you know is not the factor. But
You said that which means this one's not going to be so we're just gonna have to
Because if that one is back and that one is that was back to this one.
yeah. Six over 2 squared, and then 3 squared is 9. Well,
so these are just like the simple ones. So 1, 2, 3, 4.
okay, so like that, you have to add to that side. I did. Okay, did you? Yeah, I know how to do that. Okay, and then now you're back.
4 to 8.
Wow. And then you can just turn that square. Yeah. And then we do what we did yesterday. Like, what's the square root of 11? You know what? Okay, wait. Here's the thing where you just plus or minus. What's that, Sarah? You can just take plus or minus. Yeah, that's what I'm doing. That's what you're doing. What I'm doing. What are you doing? Maybe. Oh, Kylie, I did it.
Oh my
Yeah. You did it? Oh my gosh, you did. Oh my god. Sarah, what's the Sixth Amendment? Your mom. Sarah, what's the Sixth Amendment?
Sixth Amendment? Right up your street.
Yeah, Kasten. Woo!
Peter, what's the ninth?
The ninth?
It says
Abolish slavery. Abolish slavery. No, Isaiah's like, that's only right now.
That's what Grace says all the time.
Every time. Why not 15? Every time you make you say something
yeah.
Okay, pause where you're at and track the board. 3, 2, 1. I'm going to talk you through step by step how I solved this problem. You're going to check with your own work. If you see a blunder, raise your hand. I'm going to point out the most common blunders that I see with completing the square. Try to catch it, and if you see it, raise your hand. I started out with minus 10x equaling 11, and I got, nope, I'm on the wrong one. I'm doing 2. I got x squared plus 6x equals 2, so I need to complete the square. I'm going to put 6 over 2, row 4, track the board. Thanks for your great partner work, but right now we are discussing whole team. 3 squared would be 9. When I put 9 here, I'm going to add it, and I get x squared plus 6x equals, blunder? Tanner, what'd I forget?
You have to add 9 to both sides.
Why talking to? Super important that you Maintain equivalency. If you add something to the left, you've got to add it to the right. X squared plus 6x plus 9 equals 11. Keep going. That's x plus 3 squared equals 11. I take the square root and I get x plus 3 equals plus or minus 11. So what's my blunder? Maintain equivalency. If you square root the left, you have to square root the right. You cannot just do one thing to one side and leave it. This is plus or minus root 11, and we're going to subtract by 3 to get 2 possible answers. If you got negative 3 plus or minus root 11, you have the answer correct. If you have a blunder, check it out before moving to bronze. Questions about that step if you did not get root 11.